Welcome back. This is day 3 of a developer's guide to Windows 10 Insider Preview. My name's Jerry Nixon, and I'm here with my friend Andy. Hi, Andy. Good morning.
Good morning. How you doing?
Oh, I'm all right.
So, if you've been with us through the first 2 days, well, congratulations, and welcome to day 3. We've got loads more great stuff that we want to run through on this day. We're going to start with an important topic, which is talking about how apps, how they live and how they suspend and how they die. So it's the application life cycle.
Oh, very good.
Yeah.
How they die. Boy, that's wonderful. Sounds terrible, too.
Yeah.
All right, well, let's begin with just the application lifecycle as a whole. So this is a fundamental difference between, say, a desktop application where your application continues to run no matter what. That's not the way Windows apps work.
No, that's right. So Windows apps, they are designed to run in a very efficient way, to be nice and friendly to the computer where they're running. And this kind of comes from, if you think about the smartphone, where battery is a very finite resource, apps on smartphones are designed to, when they're not being used, they're not visible. They're suspended, not using any resources. Right. Now this model, it turns out, is not only useful for smartphones, it's useful for any portable computer or any modern computer. So this is the model we have for apps, Windows apps, and wherever they're running, and UWP apps. And an app really has 3 kind of discrete states that it can be. So when user launches your app and it's in the green box there, it's running away and user is interacting with it, and life is good. It's got the full use of the PC, the machine's resources. And then at some point, maybe the user gets distracted, maybe they get a call, maybe they go and check their email, so they leave your app. And when the app is no longer visible, it's not actually interacting with the user in any way, then it will be suspended. It goes into this suspended state where it's not using any resources. The system has taken a sort of snapshot of its memory and just keeping it there so that it could be quickly resumed. And it could be resumed just when the user returns back to it. So they've finished doing their email and they're returning to the game or whatever app it was. And
now, what is the suspended state? Does that mean that now all my resources are constrained, so I'm working quite a bit slower?
No. So when we talk about it being suspended, it really is totally suspended. It's not doing anything. It's not burning any CPU. It's not using sensors or stuff, although there's a background task that will allow us to do that. That's another topic.
But I guess I do still have a memory footprint.
Absolutely. So the system kind of keeps that snapshot of your memory so that it can be very quickly and swiftly resumed. But of course, there's that memory cache, if you like, for all these suspended apps. That's not infinite. The system has to manage that. So at some point, if an app hasn't been resumed and there's been loads of other apps have been suspended, then the system will say, okay, enough's enough. I need to get some memory back. So in a low memory situation, your app or the app might be terminated. So the system will terminate it in order to just manage its resources.
Okay, so that's the third state that we're looking at, this kind of a purple state of your app is terminated. The low memory is, suspending is an event as I go into suspended. Low memory is an event that happens as I go into terminated?
Well, it's not an event that you will get in your application, but yeah, it's a situation that the system is managing and it will terminate it when it needs to. The other way an app can be terminated is actually the user can choose to terminate it, of course. So in the task switcher on the phone, for example, you can select a thumbnail of an app and hit the X to actually close it, and then the X on the taskbar of a windowed app.
Even though you have this life cycle around your application, one thing to note, and we'll talk about this more in another module, is that there is this idea of background tasks that execute regardless of the state of your foreground app. So there is a way for you to still execute even though your application is moving in and out of these life cycle states.
That's right. Yeah, so we're primarily talking about the life cycle of your foreground application.
The reason we have this, the reason this exists is really for the user's sake, not for the developer's sake. There certainly is a burden added to the user, a burden added to the developer for the sake of the user. So they have a wonderful experience, right? As they move in and out of apps, they get the best performance possible. Meanwhile, we as developers get to account for how that's handled. And the reality is this, it's for predictable behavior for the user on every Windows device. It means I can have as many applications installed as I want, and as I move through them, the operating system has a smart enough heuristic to maintain my experience as a user. It's really nice. And maybe this graph will lay it out really clearly. So your application, so the vertical axis here is memory usage. And so let's go along the horizontal. And we start at the left and we're launched. So of course you go from 0 memory use to your full memory use, which is totally fine. And you run along and everything is good, and the user invokes suspension in some way. Now that invocation may just be they toggle over to another app. On the desktop side, maybe it's because they've minimized your application, right? Because you can have multiple apps open at once. But as soon as that occurs, you get the suspended event. And a developer then has 5 seconds, these are wall clock seconds, to save your state, to save whatever's going on so that you can quickly so that you can handle if you're terminated later. So this is a suspended, it lasts for 5 seconds, so now we're in sort of that red section. You gotta work fast, and Andy, 5 seconds isn't really very much time. If a developer's waited until then to save everything, they could actually lose some data very easily.
Yeah, so the guideline generally with modern apps is to save state as it goes on, and you know, in most apps there'll be obvious navigation events. And this is dependent on the app scenario you're in, but there's going to be
kind of milestones.
You kind of say the user's finished a task. That'll be the time to save stuff into persistent storage and to make sure
that's right. Even if you're not saving it out to a database, you can save it just for a moment. That's right. So you have those 5 seconds, and then your 5 seconds pass, and as those 5 seconds pass, your UI is being pulled down so that you don't have as much memory usage, and then you can see we go into this purple state, which is your suspended state, and that's where you have very low memory utilization, but you don't have 0 memory utilization. That's the reason you might actually be terminated, is because that will compound with other applications that may also be in the suspended state on your app. So then we go back, and the new event fires. That's the activated event. So I'm activated, and I will get a resuming event, perhaps, depending on if it's fast switch. And if it is, then I get a resuming event. I can handle that. I go back to my normal memory usage.
Yeah, and the kind of stuff you might want to do when you're reactivated, on the whole, is probably not a lot, because your app just starts running again. But things that you might need to think about is if your app has a
socket.
As a socket, exactly. It's doing networking stuff. You might need to make a call again because it hasn't completed. Or if your app is one that is time dependent, you might need to reset a timer or something like that. But in general, it will just come up and carry on running. So it depends on the app, but it may be that you don't have to do anything.
It's worth saying that this suspended state can actually be maintained indefinitely. So if the user hasn't, if there is no constraint on memory and you're not pulled down and terminated, then your application could remain suspended for 6 months. I mean, in theory, right? There's nothing really to stop it from happening. What that means is, Andy's 100% right, you need to check the clock and see how long it's been. Maybe it's not appropriate for you to keep rolling anyway. Anyway, you go back into a running state, use all the memory that you would expect. You're suspended again, and you go into a suspended state again. That's the same as before, but in this case, you go to not running. You're terminated, and there is no event, nothing for you to handle, no way for you to know that you're being terminated. That means when you go into the suspended state, you really need to act as if your app is about to be terminated.
You have to assume that termination is a likely outcome. So yeah, when you're suspended, make sure that everything's saved away to your storage, whether that's a files or a database or whatever, so that you have to assume that in the next time your app is run, it's actually being run from a cold start sort of situation.
Yeah. So one interesting takeaway is desktop family apps. Those are apps that run on the desktop. It's not a SKU, is it? It's the
desktop device family.
Desktop, device family. They are suspended when they are minimized. So where a mobile app, when you no longer see the pixels, it's immediately suspended. That's not the way it works on desktop. When you can no longer see the pixels, it's just behind the window and you can move it over. But when you minimize it, then it is suspended. Very interesting model, different 100% from the way it was in Windows 8. But good to know. We could stop now, Andy, because that alone covers the whole piece of suspension and lifecycle. But we haven't really talked about how to deal with it.
No.
But and honestly, it's a struggle for some developers to wrap their head around. It's a struggle for some developers to know how to implement it. And so it's nice that we have some things here. At its basic level, handling suspension is simple code. Inside your app XAML CS, there is a suspending event as well as a resuming event that will be raised by the application class. And so right in there is where you can handle it. Passing then the suspension event into your pages that are open, into your view models that are open, into all the things that need to be saved. That's where it sort of becomes complicated, because this is an event that doesn't necessarily flow into all the other pieces. And we'll show how we handle that, and we can give you some easy techniques to deal with this. But nonetheless, in the suspended is where I would quickly save. Again, I only have 5 seconds. And then in the resuming is where I would check for timing. Maybe I need to clear my cache and things like that as well. There is a previous execution state in enum, not enumerable, enum. And this is not going to occur on resume. This occurs when your application is launched again. And so you would ask yourself, why am I getting, for example, terminated, right? The reason I would get terminated is because your application was suspended, and then because of memory or whatever, maybe the user rebooted, your application was terminated.
Yep.
That's great, because now that your application is launching again, I can detect that I was terminated last time, and maybe I could give the user the experience of coming back to where they were.
So you said before that there's no event when your app is terminated. So the only way you can kind of react to that event is the next time it's launched, you can look at that previous execution state and figure out, oh, okay, so last time I was in existence, actually I was terminated, and that might influence the way that you start up again. Not in every case; it's not something you need to know necessarily, but. Yeah.
Some developers ignore this altogether, but not all apps are great either. The navigation model inside a Windows application, we have a module dedicated to that, but in general, it works like a browser, so that you have a frame and then pages that navigate inside that frame. Well, just like in a browser, if you're several pages deep, the application is terminated and the user returns to your page. Do they need to navigate several pages deep again, or are you going to take them all the way through in that stack so they have an experience like they're coming right back into your application? It's really up to you, but how do you do it? You do it with the frame itself. Has a couple of methods to enable that, Andy.
Yeah, that's right. So the frame keeps a track of, as you navigate through pages, the frame is keeping a track of that and storing that navigation history, its navigation state. And what these methods do, get navigation state and set navigation state. On get navigation state, this is what you can, when you are suspending, you can call frame.getNavigationState, and that returns to you a serializable representation of the page history, where the user currently is in your app. You know that they
both the back stack and the front stack, and the ability to go forward.
Yeah, that's right. So you can just get from the frame, okay, this is a snapshot of how the user has been interacting with your application up to this point. Now, when you resume, from termination, this is from termination, because if you just reactivate, all of that history comes back in. It was just stored in memory anyway. You don't have to. You haven't lost anything. But if you're resuming from termination, you can call frame.getNavigationState and get back that serialized navigation history. Now,
you would do that as you suspend. Actually, you would set it, right? You would set it as you're resuming.
Yeah, exactly. So that's what I was about to say. So when you come back and you say, okay, we're back from terminate. We were previously terminated. Yeah,
that's right.
So you've previously saved the navigation state into your storage. So you're coming back from termination. At this point, you say, okay, do I want to put the user back to exactly where they were before, or do I want to start as if it's a brand new launch? And there's no hard and fast rule for that. That's for your application to decide. And sometimes you need to look at how long is it since I was terminated. If it was like 3 weeks, it doesn't make sense necessarily to put the user back exactly where they were on page whatever in your application. Right. So then you probably want to just launch and just as if it's brand new, because that's you kind of have to put yourself into the user's head and think, what would their expectation be in this situation?
Yeah, that's right.
But if you are resuming from termination and it was only like a few hours ago, then it might well make sense, and this depends on your app, to put them right back on the same page where they were. So this is where you can pull the navigation state that you have serialized, that you've saved away into a file or something, pull it back in, and then set the navigation state, put it back to where it was. So you can actually, effectively, the user doesn't know that you've been terminated, that you can give this illusion that you've never been away.
That navigation state that you get from the frame includes the parameters that were passed to that page as well. And so when you rehydrate that for the user, they don't only get where they are as far as being located, but they also get the parameters passed back into it as well, so they get the full fidelity of it. And so that's a string, and there's a best practice of when you do pass parameters to pages, be sure and pass strings because you want to make sure we serialize them. MSDN already recommended that, but because the namespace or because the method uses object, it seems as if you could pass classes around. But a lot of developers, that's a hitch for them because it doesn't serialize all the time. Some classes simply use properties that aren't serializable. All right, so that's the concepts. Let's talk about how we do this in Template 10. Remember, Template 10 is our new project, a new app project template, new app project template.
Yep.
And this is how it's handled inside, and it makes sense that if Template 10 works for you and the approaches, then use it. If it doesn't, obviously you don't have to.
No, yeah. So what we mean by that is handling this, the navigation history and serializing and saving your navigation state and bringing it back. There's a little bit of complexity in there, and various people what you tend to do is use an existing framework that handles that for you, or you roll your own solution for that.
Because most developers roll their own.
Yeah.
This is nice for us to give it. Let me show a quick demo here of handling suspension in 10 here. All right. So I've got a blank application ready to go with a details page. So this is so I can navigate from my main page to my secondary page. Let me just run it so I can show you how it works. It's super duper simple. I have a button on my main page that says go to page 2.
Oh, this is the UI to die for.
It's pretty incredible.
Yeah.
Here's my secondary page, a couple fields in default value, right? I can say Jerry Nixon for, Jerry Nixon, right, for my last name, right? And so I forward and backward are all supported, and that's because of Template 10, right? It supports all these navigation gestures as well. All right, so now let me show what would happen is I want to add the debug location. This is a toolbar where I can add lifecycle events, and I can cause a suspend. This is the only way to do it while we're debugging. So I can cause a suspend and the termination, and when I run it again, you'll see what happens is I am brought back to the second page because Template 10 does that for me, but you can see all the values are back to default. So that's what we're going to try to fix. We're going to try and handle these lifecycle changes.
So we want to get back, we want to save the user state so they get back to exactly how they were before.
Yeah, so this is the view model for that second page. Has 3 properties, and that's it. So we're going to override a couple methods off the base. The first is onNavigatedFrom. OnNavigatedFrom tells us whether or not it's suspending while it's moving away from this page. And if it is, it passes us a state, which is just a dictionary object. And so here I can say, all right, state, I can say item first name is the first name property, last name is the last name property. Obviously, this would be up to me. If I needed to serialize something, I would do it right here. And so now these all get put into state for me, and I don't have to think about state. It gets saved for me between sessions. So I'll override another one. That was onNavigatedFrom. This is onNavigatedTo. And so onNavigatedTo, now the user is coming in, and a couple of neat things are happening. One, I get a parameter passed to me. We'll talk about that later. But the other is I get passed a state. So the first thing I can say is this property, or this class's first name property gets set to the state, the value of first name in the state. And then the last name, and I'll just repeat this, right? I'm pulling, first I wrote to the state, now I'm pulling from the state. And so here's last name, and then finally email. I suppose it's possible that even if those exist, they could be null. And so thanks to C# here, I can go in and put a quick little question mark period. And if it is null, it just returns null rather than throwing an exception. And then I have that finally just to clear the state, because this will only happen once. If it's suspended again, I would save it again as well. So there's no reason to keep it there. So here we go. Here's the application. I'm going to go to page 2. And let me clean this out here. And let's take a look at the view model. So automatically, I get onNavigatedTo running. Nothing's going to happen in this one because there's no values in the state dictionary. So I'll put my name in a couple fields, and then let's fake out my suspend operation again. So here we go. I'm going to suspend and shut down. And you can see onNavigatedFrom runs, and suspending the Boolean passed into the method is true. So that means I want to write out to this state dictionary these values for me, and then underlying the bootstrapper will handle all of the rest of the work for me. So I'm going to run it again. Remember, I'm coming from terminated, and so here I come. I'm coming in. onNavigatedTo fires every time for a view state or for a view model, and I can write these values out, and there they are. I'm pulling directly from the dictionary, And the user's experience is, even though it was terminated, which could actually happen without them knowing it, they don't care. They come back in, and the application looks like where they left off. So it's really that simple. Hopefully, Andy, it looks super simplistic because it's meant to be, right?
Yes.
And so this is not the way it works out of the box for Windows 10. The blank app doesn't. The blank app template that ships with Visual Studio doesn't include this sort of functionality.
Nope.
So a lot of developers write their own kind of frameworks to build out just this.
Yep.
Template 10 just ships it for you.
Yep, so it's just out of the box, which is pretty helpful.
Yep. Anyway, so let's just review what we did there. So this is the on-navigated from event. So this is as I go out, I get that suspending. Of course, I want to test for suspending. I don't want to save to the state every single time I'm navigating. And then I also have this on-navigated to event, which passes in the parameter for me. And let me back up. The parameter for me, but it also passes in the state. And so here I'm using the state and just basically setting everything up. I put it all in a try-catch because it is possible that that state is empty.
Well, yeah. In fact, when you first on a new navigation to the page, it is absolutely empty. So
that's right.
Yeah. So
that mode, by the way, is
yeah.
passed in. I could test for that if I wanted to.
Yeah.
But if I was lazy, I could just throw it in a try-catch and go from there. I did
really
this.
what you've done.
Yeah, let the code speak for me. That's right. All right, here's where you would go and get template 10, aka ms/template 10. By the way, it's in GitHub, and we'll take pull requests, of course. There's a team of people that are contributing to it already, and you're welcome to be part of that as well. So that's template 10 and how it handles suspend and resume, and what suspend and resume means to Windows 10 or just Windows applications in general.
Yep.
There is another fascinating concept, and that is around extended execution. Extended execution is basically preventing suspend or extending suspend.
Yeah.
And so what we're doing is we're asking for something from the global resource pool. There's a global resource pool that makes it so that many things that are working together that have constrained resources can kind of tap into this pool. And if they do tap into this pool, it keeps the overall operating system running smoothly. So it's kind of a fail-safe block of resources.
So are we kind of talking about stretching the scenario we've just talked about and some special edge cases. So if you want to kind of do something that doesn't quite fit into the life cycle that we've just been through, this is the way you can do that.
Yeah, that's exactly right. It's a formal way of asking for some of those fail-safe resources. And so there's two scenarios that you would potentially use for this. The first one is I have data this time. So this is a normal suspend operation for me. I'm looking to see if I need to save anything, and I do. I'd like to save even more. I can save just a little, but I'd like to save even more. I'd like to request more time. So that's the first kind of extended execution.
So this is where you think you might need more than that 5 seconds.
That's right.
Yeah.
The reality is, though, you won't get it if it's not available. So it's not a guarantee for your application, but it is available if it is available, it'll be given to you. And you can ask if it's available, and so it's not a total mystery, and you'll be able to respond to that. So that's the first one, and we'll look at the syntax for it. Then the next one is I'm a special kind of app. So maybe you're a turn-by-turn navigation application that needs to stay open, and this is basically you instructing the operating system, look, I'm special, and you can't suspend me. The user relies on what I'm doing. And once the operating system is flagged for that, then your application won't be suspended whenever the normal process goes through. So that's pretty cool. And really this is a balance of the user's experience on loading things up, and it's a balance of the developer's experience on shutting things down. We want to give as much time to you, the developer, to be able to save and create state for your application, but we also want to make it so the user's experience on loading the next application, whatever that is as great as possible, right? So that balance is delicate, and honestly, the user will always win whenever it's a tight race, right? We want the user's experience to be great, and we want the developer to figure out a way around it. We don't want the user to figure out a way around it. So this is the first scenario, type 1. This is where my application is running, so follow along in that green box. Your application's running, taking up all the memory that it wants to have. Then suspended occurs. When suspended occurs, that's when you ask for that extension, right? So that's when you look to see if you have data to save or not. If you do, you ask for the suspension. If you don't get it, you as a developer get to figure out what you do if you don't get it back. So you have this red section, right? So you go into this red section. You have no UI or any interaction with the user, but your application continues to roll, and you continue to save or whatever until you get a revoked event. But a revoked event is a 1 second delay, or a 1 second event. So you basically will get the revoked again, and the rug will be pulled out from under you in 1 second. So you have to act very fast then.
Yeah.
I would say from a developer's point of view, that 1 second is just enough time for you to write out somewhere that I didn't get to save, right? So that when you come back into your application, you can alert the user to say your previous session was lost.
I tried my best, but we couldn't do it. Yeah.
Right. Don't forget to click save or something like that.
That's right, yeah. And in general, I suppose, this isn't something you want to try and use just on a regular basis. This is a special case thing for a particular scenario. So, like we said earlier in this session, if you can save your data as you go on, that really generally is the best course of action. But if you really have some stuff you have to do at this suspend time, well, then this can give you a little bit more of a lifeline to try and do the job properly.
Just remember, it's not reliably there.
That's right.
This is what the syntax looks like inside the suspending event handler. We create the deferral just like we would normally, and then we create the extended execution, and we give it a reason. So in this case, there are 3 reasons we would be able to give it. This one is saving data, and this is when we will get then a response back right here, right? We say request extension async. It will give you a response back of whether or not it's denied or allowed. And if you're denied, obviously you do the shortest operation possible so you can work inside the standard 5 seconds. But if it's allowed, then you go ahead and start a longer operation. But don't forget to go ahead and handle the revoked event like we did here. So because even though it's a longer operation, out of the blue, you could still get the revoked event if the user's doing something really high end, right? That's the issue. So extend the suspension for the foreground app. So this is special cases, right? And this is what it looks like in those special cases. Your app is running, that's the green section, but that is also when you ask for the suspension. So you don't wait for when it's suspending. Sorry, not for the suspension, but for the extended execution. So you don't wait until you're suspended. You ask for it straight away. And basically, you're setting up a category for your app, and you're getting your app into a special spot registered inside the operating system. So now suspension occurs. That's when the user navigates away. You actually do lose a little bit of UI. And so I'm not UI, but use a little bit of memory usage because your UI is away. So that part is nice. And you're about to be suspended, but instead of getting suspended, you're automatically extended and you continue without a UI. Of course, at any time, the user could cycle back into your app and you would get your UI back. But this is you almost like a default background task. It's kind of how it works. But it makes sure that the user's expectation of how your application works is what they actually get.
Yeah, and as Jerry says, the classical case for this is a turn-by-turn navigation, which is something if you were trying to build this in Windows Phone 8.1, wasn't supported in WinRT on Phone 8.1. You had to use a Silverlight app for that. But as you can see, this is now fully supported right the way across UWP, so no reason not to move.
Important to look at this last event at the very end that even though you're running in this long-running session, it still is possible for a revoked operation to occur. The reason that could happen is the user still could be overtaxing your operating system so that all the memory is being consumed, and the operating system will start slicing off applications that are using memory, including yours, if it has to. So it's not a guarantee you'll run forever. What it is a guarantee that you'll get precedence over everybody else. That's the important part. So this is about preventing termination of a foreground application. Requesting it, by the way, looks just like this. We create the session. The syntax is almost identical to before, only it's happening during runtime. And we say the extended execution reason is location tracking. That's as good as it goes. You ask for it, and if it's approved, then you keep on rolling with your application like you would expect. If it's not, you need to indicate to the user your application is not going to respond the way that they expect it to respond. The only reason you would ever get it denied would be if you're the second location tracking application running on the system. So you can only have one at a time. Could I write a notepad app that says it's a location tracking application to prevent suspension? I actually can. And so you got to be a good citizen inside the app ecosystem. And the user, of course, gets to see what's going on. They know that your application is doing this to them. But nonetheless, why would you get a not allowed? The reason is because there's already one running. That makes sense. You can't have too many
No.
always running applications
You couldn't
in the
have
user's experience.
you couldn't have 10 of these apps in extended execution. You know, it's all about protecting the user experience and making sure that you can't kill the machine.
That's right. So extended execution is a formal request for the global pool, and the global pool supports burst events. All these things are happening. That's the reason you have this fail-safe of global resources. This is the way you can ask for that pool to give you some if it just happens to be idle. On a desktop application, on a desktop machine, you probably have a lot of resources asking for it. You can almost be sure you're going to get it. Not a guarantee still, but more than likely you will. On a very low-end phone with very little memory, you could ask for it and almost be sure you may not get it 50% of the time. So it just kind of depends. If I'm writing a line of business application, I can probably assume I'm going to get this most of the time.
Yeah, interesting stuff.
All right, that was the application lifecycle for Windows 10 applications. We talked about how we handle it specifically in template 10 to just make it simple so that we can do everything inside the to and from events in our view model. And then this new thing of extended execution to make it so that the suspension time is longer, but to also make it so that we don't get suspended in special cases of apps.
Great.
Pretty cool.
Good. Right. Well, thanks. That wraps that session up. We're just going to take a short break, and we'll see you soon for the next session.
Perfect. See you soon.